our own AI. We'll explore. Help the future hand in hand in this tech-driven wonderland.
Okay, hello everyone. We're live. That's episode. I never remember the number of the episode, but that's episode number next of Near Office Hours. Today is a topic that I'm particularly excited about. It's a trusted execution environments. It's something that a lot of people in the AI space and Web3 space are excited about, and potentially one of the very few practical ways of achieving certain features that are extremely desirable. So we have two different companies with us today. We have Phala Protocol and Super Protocol. Oh, it's Phala Network. Sorry. Yeah, guys, do you want to introduce yourself? Nukri, you want to start?
Yeah. Thanks, Alex, having me. I'm Nukri. I'm founder of Super Protocol. About 14 plus years in area of decentralized confidential high performance computing. Third, this is my fourth startup in this area, and yeah, thank you.
And do you want to give a very quick overview of what Super is?
Super is a combination of marketplace for AI ML agents and decentralized confidential cloud. I believe this combination will be successful to resolve many tasks we see today in AI and crypto area.
Okay. Yulia, you want to give a quick background on yourself?
Yeah, sure. Yeah, I'm ex-Intel actually. Yeah, so I've spent 18 years, more than 18 years at Intel, where I led large-scale projects, developed incentive programs for Intel consumers, and championed and enabled confidential computing. And while I was still at Intel, over the last 10 years, last ones, I also worked closely with Nukri and his core team in order to support and drive various projects related to secure, decentralized computing and IP technologies. Now I am a CEO at Super. I oversee operations and business development and work with different partners to extend the whole ecosystem for confidential and AI and self-sovereign AI. And specifically, I also own the direct relations with major TE manufacturers, which are NVIDIA, Intel, AMD, and ARM. So yeah, excited to be here.
Awesome. Okay, and Hank, do you want to give an intro on yourself and what Phala does?
Sure. Yeah, so I'm Hang Yin, the co-founder and also CTO of the Phala team. And the Phala is actually a very old project, probably close to how old Near is. Yeah, we have been building in the TE space for 5 years. Since 2019, we started the project aiming to solve some of the problem the blockchain always have. One of that is that you cannot really deal with the confidential compute or confidential input data on the blockchain, because whenever you put everything on the blockchain, it's transparent. So another thing is a lot of limitation, like you cannot do the heavy computation on the blockchain, or you cannot access any data outside of the blockchain. So all those kind of limitations are non-existing in traditional cloud. So that's when we were thinking, why not to bring something similar to cloud computing into the blockchain space. And after checking all the related solutions, TE is the only practical solution we have found so far. So that's why we got so passionate about building on TEE. So in the first few years, we have been focusing on bringing up the cloud supply. So we have a network with more than, I think, 40K nodes joining the network. We know none of the nodes. So all of those nodes are provided by, the individuals or some miners. As long as they have the hardware, they join the network. And the developer can hire those miners by paying them, and the miners are going to run their workload on their decentralized cloud. So this is what we have been doing in the past few years, and this year, it's never more make me more excited, because now we have very solid demand, especially from the decentralized AI space, and we have never good supply of the TEE technology. I mean, the next generation of the TEE. Probably we can cover in this podcast as well. So yeah, combine them together. I think this year is going to be very excited for the project using TEE.
So I think a good way to start would be to explain what exact guarantees TEs give, right? Because I think people talk a lot about TEs, but not everybody understands what are the precise guarantees you get, right? So, like, for example, can I be certain that a very particular code is being run, right? How do I know, like, if I'm encrypting my data, how do I know that it's only decrypted within the TEs? Who controls the key for decryption, etc., right? Yeah. So Hang, do you want to give like a quick overview of how TEs work and what guarantees they provide?
Yeah, sure. Yeah, I think a good analogy to think about TEE is like a black box. It's just like a black box. You can put anything in the black box, then it just run. The black box itself has the characteristic to make sure everything running in the TEE is secure, is tamper-proof, is privacy preserving. And because it's a black box, so from anyone outside of the black box, you cannot really do anything. You cannot really manipulate anything inside the black box. Say you cannot steal the data inside or manipulate how the program is running inside. So this is the mental model I usually describe how TEE look like to the people are not familiar with TEE. But this just sounds a little bit like too good to be there, right? Why can we have such a thing that's so easy to use and has so good characteristic, especially compare with the cryptographic solutions like zero knowledge proof and MPC FHE? They usually have a very high overhead, like if you put something running in zero knowledge proof, usually you get an overhead of around maybe 100 times or even 1,000 times. For FHE, it's even higher, like 10,000 times. But for TEE, it's just like a CPU, but a CPU in the black box. So there's no really very high overhead. It's just like a 5%, 10% ish. So why it can be so nice, and is there anything wrong with that? The answer is TEE actually has a completely different security assumption and threat model compared with ZK, MPC, and other cryptographic solution. So there are a few things. First, we need to make sure TEE itself is done at the hardware level and it's done in a right way. There can always have some bugs in the hardware, but of course, people can also have bugs in ZK implementation, but that's just the same. There could be bug in the implementation. And second, whenever you put something running in the TEE, you want to make sure once you interact with the TEE, you can make sure, okay, this is the right program. And the right program is put in the right environment, which means that the program you are interacting with is not, some fake program. This is the first point. And the second point is the program you're interacting with is really running in a authenticated TE instead of a fake TE. Otherwise, if you put it in a fake TE, anything is leaked. There's no protection at all. So the way to do that is something we call the remote attestation. I believe we can cover this a little bit later, but basically you can take remote attestation as a proof. So you put the program run in the TE, so the TE give you a proof. You can verify the proof so that you can be convinced that this is the right program. It's running in the genuine TE hardware.
Yeah. But I think a couple of things that, go ahead.
Yeah, I can add just TE isn't like something super novel tech. It's well known many years. And when you use iPhone or you keep your wallet ledger, or just Apple announced they're developing a data center, a TE-based data center to keep private data for AI purposes. Everything and everywhere TE will be used. Same time as TE is a gold standard, to say truth, because all well-known manufacturers who are developing CPUs, GPUs, they are TE compliant. You can use large chips, high-performance chips with zero, let's say, degradation on inference, and you can use it easily. But same time, TE has implementations, a lot of implementations in our previous projects, Project Egregion. We worked using TE. We worked with top copyright holders to prevent and to distribute intellectual property through huge chain of resellers, distributors. We worked with big data. I will say later why I'm mentioning, but this is very important. We served 150 million users, unique profiles, including all personal data for digital collaboration, ecosystem collaboration purposes between telecommunication companies, retailers. Processed in peak about 1 billion transactions daily of personal data using decentralized distributed confidential computing network to prevent leakages, to prevent business collaboration. And what is the most important, when we talk about TE or another alternative technique, we always should remember that confidential computing or in different implementations is not only about how to prevent data leakage or to prevent to keep privacy. It's always about how to run applications, how to run virtual machines, how to allocate resources, how to make it scalable. Who will be responsible? In alternative tech stack, who will provide this deployment or network solutions, which will guarantee to your user scalability and as general basic SLA. And there are always open questions. And TE, why TE is additionally, why TE looks very interesting and promising. There are a lot of instruments developed for TE by major vendors and open source communities, and you can easily deploy it and run your TE-based infrastructure with no limitations, with no degradations regarding scalability, maximum uptime, or log, or any other integration, and using integrations with external drivers, operational systems, and so on, and using popular development tools. It's in complex. It's a very important thing when we are talking about mature technique to provide our services through ecosystem.
I wanted to quickly close a couple of questions that I personally found interesting a couple of weeks ago when I started digging very deep into TEs.
Yeah.
Well, I guess just deep, let's say. So first one that was not obvious to me, but I want to to make sure that people who listen to it understand that this is the case, is that with TEs, I get the guarantee that the code that is executed within the TEs on my data is indeed the code that I believe it is, right? So like the owner of the hardware cannot swap in the code inside the TE, right, and run something else, right? Which I think is like that's not like naturally. Once you start thinking about the use cases, you understand that this must be the case, right? But I don't think it is necessarily obvious immediately that this is the case, right? So like there's an attestation that the code executing in the TEs is a very particular piece of code, which I think is very important. And the second thing is that the way the security is established is by TE internally has a private key, right? That does not exist outside of it. And then the manufacturer of the hardware has a way to confirm that the public key is in fact, the public key matching that private key is in fact something that I should be trusting, right? Is that more or less the mental model of the TEs?
Yes, exactly. How TE works. First of all, I mentioned that TE is a well-known technique. You are using everywhere, every day, including your iPhone. And how it works when manufacturer is, let's say, developing this crystal of silicon crystal, they implement function, a specific function for each processor, and this function collects like dark a few parameters from this specific CPU or GPU, and creates this function and burn out this bridge between cheap outputs and your internal crystal part of TE. And in this way, this function creates this pair of public and private key, and you can use, and of course, this is to say, it's not black box, to say truth. It's a verifiable black box, I want to say. It doesn't work like we put something and we don't know what happens inside. No, you just have simple solution. You can create, using your private key, encrypted enclave, secure enclave, managed only by this private key, non-rejectable private key. No one can reject this private key, but same time, you can make this process fully verifiable. It means that you can attestate this key CPU or GPU. That's why T-based server could not be faked, because you can't fake this process. I mean TE. Same time, you can create open source software, which could be deployed on your CPU or GPU. You can create these verifiable enclaves, and you can create smart contracts, which will govern these processes inside of this verifiable attested environment. It means that using TE, this is just for the general overview. It's a just pair of private and public key, and private is non-rejectable. But same time, you can manage all processes inside of this, let's say, box. And that's why it works very well for distributed computing, because when we talk about distributed environment, distributed suppliers who are providing your infrastructure for your project, should I trust them? I mean, distributed and well-known DPIMs, right? Should I trust someone, I mean, John, who is from Texas, who is owning server where I should deploy my business? No, from my point of view, TE is a very important part of this decentralized infrastructure, because you don't need this trust to John or someone else, from one side. From another side, this part of public-private key-based infrastructure, non-rejectable private key infrastructure, TE, could be managed by smart contracts only. because no one has access inside of this. And if you are deploying your open source solution where all services could be managed by smart contracts only, you can guarantee to all participants a few important things. First of all, no one can reject or manipulate with your data and services because everything works inside of this enclave or group of enclaves combined in clusters. Easily, by the way, a step back in my previous sentences about ready-made solutions to create clusters or pools, and same time you can guarantee to your users regarding collaborations, data integrations, data flows, services integrated with each other, that no one can manipulate with these services too, because everything is based on governance by smart contract. These two important things give us very interesting possibilities for AI, specifically for AI area, because today AI is we are developing AI gods, right? We see a lot of projects who are developing vertical solutions. They're collecting a lot of data. And from my point of view, Web3, crypto AI industry has a super chance to make something super interesting in area of combining infrastructure, decentralized, governed by smart contract infrastructure, self-sovereign infrastructure, with crypto narratives in AI. And these possibilities are very important from my point of view, and comes just from this simple idea of non-rejectable private and public keys.
So,
and Alex, if I may just add, because on the one side we're talking about TE, and this is some kind of a common standard. On the other side, me is working a lot with the ecosystem, with GPU providers, with miners, with the AI projects. What I actually see is that there are people who knew and learned about TE some time ago, when there was no NVIDIA GPU TE, when there was no Intel TDX, for example, with AMD SEV was not paired with H100 in order to drive confidential mode. And for these kind of people, they believe that this is Intel SGX, for example, and it has its pros and cons, but this is all what TE can do. And now we're in the mode when combining H100, H200, and Blackwell, this kind of GPUs, if they are enabled in TE mode, compared with the right CPU, could bring up absolutely different approach to how we can treat AI, how we treat TE in general. And what I witness is that still a lot of ecosystem members still miss the capability of what NVIDIA GPUs can offer if they are not used just as an accelerated GPU, but really use the best part of it, the confidential mode itself. And so this kind of thing that, for example, you buy the system with 4 GPUs of H100, and literally you cannot use it in confidential mode because it does not offer the needed configuration, for example, right? So this kind of things that we constantly work with the whole ecosystem in order to explain these TE standards and what they can offer, only if they are offering to the market the GPUs, for example, instances in a proper way. If it's like one single GPU, H100, plus specific CPU, either AMD SEV or Intel TDX with the 5th generation SKUs. So these kind of things. And until we make them understand that there's much more opportunity if this knowledge becomes much more available to the market, the more opportunities would be really happening on the both sides, on the supply side from the GPU providers, miners, cloud providers, etc., and on the top side, on the demand side, where people could really start using the confidential computing in the way that they really need it, in confidential and self-sovereign mode.
Yeah.
So
totally.
you mentioned, go for it, Chaim.
Oh no, just say totally agree with that.
So as a person, well, I have two immediate questions. So let's begin with the one more relevant to this awareness, right? So let's say as a person, I want to buy a machine that can be used like as part of, one of the clouds with TEs, right? How do I know if my machine is properly configured? Like, is there an easy way, like other websites that will tell me which CPUs work with what GPUs, or like, how do I do that? How do I not accidentally commit a lot of resources into a machine that will not be appropriate for this use case?
Yeah, this is going to be hard. Yeah, we actually recently we have built a few bare metal servers. So as like your question mentioned, this is like you buy some hardware, then how can you make sure this hardware can work? And it turns out it's really not something very easy. First, you need to have the right hardware, which is for CPU, you need a CPU for like Intel CPU, you need it to support Intel TDX. So usually you will need the 5th generation of the Intel CPU. And for GPU, there are only 2 GPUs supporting the TE right now. That's NVIDIA H100 and NVIDIA H200. And if you put them together, usually it should work, but it's not the end of the story. Then you need to deal with, the operating system, the BIOS set configuration. And even for the operating system, you're going to tweak a little bit in the Linux kernel because everything is super, super new. H100 was just available since last year, but there the CPU you have to use was not available last year. I mean, the Intel CPU, AMD is a little bit earlier, but Intel CPU was only available this year. That means when you are using the combination of the 2 hardware, now it's like you are the early bird tester for Intel and NVIDIA, but it worked pretty well. The only point is that you will need to figure out how to configure that, some customization in the Linux kernel, the NVIDIA driver, and also how to build the virtual machine image to boot it up. So it's a little bit pain on the ass. We have spent roughly 3 weeks to figure out the configuration for H200. Yeah, we haven't tried AMD yet, but Intel with NVIDIA GPU is good.
I just want to add a few words. H100, H200, they play the current AI market, right? And all providers wanted to support confidential computing because I don't know, to say truth, I don't know server chips, supporting H100, H200 without confidential computing possibilities. I mean, this is a trend. And not only, let's say, infrastructure, hardware, software is implementing. We see a lot of integration support by the way, ARM and other players who are developing a lot of integration software to support this confidential computing. The huge players like Google, Microsoft, Apple driving confidential computing. That's why it's not like local play. Let's play something, with confidential computing. No, guys, huge data centers are developing it. That's why we are believer of this tech.
And I will just add from the like super protocol sources actually. So what you need is you need to have the right hardware, and these are very these are very easy to get identified. But once you have this hardware in place, then all you need to do is to onboard, and then you will have the super protocol image that will allow you to forget what confidential computing is. You just plug in, right? You have the right image on board, and then the whole super protocol system helps you to offer confidential computing without you knowing and being an expert in confidential computing space in general. And for example, in June, we had workshop driven by our CTO who demonstrated how to use H100 with in confidential mode. With smart contracts. So it was really a demonstration of what super protocol can do, and it's available on YouTube channel of our super protocol side, right? So just to have an image what can be done, right? It's not some theory, it's just like it's already available to see how it works. And we are planning to soon start onboarding the GPU providers and miners interested to be part of super protocol ecosystem, specifically for driving this confidential self-sovereign AI in reality.
Yeah. Exactly. All miners are running H100, H200. There are a lot of suppliers on the market, and we see a lot of requests how to involve these chips in AI, crypto AI infrastructure.
And Alex, just to support your comments regarding how users can actually identify, I do believe that still there is a gap, the knowledge gap between what is TE, what's confidential computing, and how the mass market should know about that for sure. So we do have already plans of writing a joint partnership articles in order to reveal this kind of to close this gap between what needs to be purchased, what is applicable, what are the technical requirements, why, what kind of capabilities they can open up. And even if you do not onboard the hardware at the moment, if you buy the right hardware now, you have this kind of a long-term, opportunity to onboard whenever you are ready to go, in case you have already, right hardware and specification in place. So definitely there is a gap between. I'm working with our partners and with TE manufacturers as well, because we share with them the knowledge of what Web3 all, what is permissionless, trustless, all these kind of things that they actually do not know, right, to some extent, because they were always about Web 2 world. And because AI, it's not about Web 3 or Web 2, it's about the opportunity to drive confidential self-sovereign AI. And that's where actually confidential computing comes in. So no matter from where you are coming from, the more you know of Web 3 and confidential computing, if it's cooked together properly, that's how the community itself will learn much more and start using it. And that's where we are closely working with the ecosystem to do that, as soon as possible.
Yeah, just a one-liner, trying to add up something here. For the user onboarding journey, no matter it's B2B enterprise level customers or it's very retail customer, we find it there's the barrier for people to understand TE besides the educational journey you mentioned, Yulia. Besides that, there's another barrier, which is the reachability of these chain of trust in TE technology. So basically, chain of trust means that it's not blockchain, right? It means that when you see something, you can verify this information based on algorithm to the next step. Step by step, people can actually, maybe they get a hash, but from the hash and Mocha tree, they can verify eventually where the root of trust is coming from. And in these steps, there is some maybe a security assumption to verify the trust. So we find it out no matter it's for Web 2 clients or the Web 3 clients, there's a big barrier for them to understanding, and there's no tooling for them to test it. Of course, you can, for example, in NVIDIA H100, you can do remote attestation for these inference results coming from the model running inside GPU TE. But the problem is can they verify them on chain, and the retail people, they don't even be able to get a proof on blockchain and use it to track back where's the verification coming from. So we see this as another barrier, and our team is trying to figure out that problem too. Yeah.
So I have another sort of interesting, another thing that was not obvious to me before I started looking more into the TEs. So I think it would be a nice thing to cover is that when we talk about CPU TE, I think the mental model, the way I see it, right, and it's a very simplistic model, is that there's a key inside of the I mentioned it before, right? There's a key inside of the chip, right? I can always go to the to Intel and say, is the public key valid or right? And then anything that is encrypted with that key, I know that was computed inside the TE, right? So as long as everything else around that I verified, I made sure that the code was the code I wrote or the code I trust. Then I know first of all, the data I sent, if it was encrypted with that key, it would be decrypted only within the TE, and any data encrypted with that key was actually computed there, right?
Yeah.
So with CPU, it makes a lot of sense. Now with GPU is not a general, it's much less generic compute device, right? So how does it, I cannot send code directly to the GPU, right? So how do I, as a user, so I'm sitting in front of my laptop, somewhere in Texas, there's an H100. How do I know that the code on H100 is the one that I have? Does that make sense?
Yeah. Actually, I think probably I can share the screen because I just have a diagram to show that. Yeah, let me do that very quickly. So here we go. Yeah, can you see that?
We never tried sharing screen on this StreamYard before.
No.
Maybe you need something from Jared.
It's not on the screen yet. Yeah.
It's not available yet. Okay. All right. So yeah, let me just simply describe that. In CPU TE, yeah, you have the key in the CPU. The CPU sign the proof, so it can make sure, okay, this is the right program, is deployed on the right hardware. And on the GPU TE side, the thing working this way. Oh, it's showing. That's nice. So you know, at the left side, there is the CPU so-called root of trust. It's basically the key mentioned by Alex. There is a key here, and on the right side, this is the user, and the user gets something called remote attestation. This execution, this proof is signed by the private key in the CPU, and because only the right CPU has the key, so everyone can verify, okay, this is the right proof, proving that your program is running in the right environment. And of course, another related thing is how to verify the code you deployed is exactly the code running in the TE. It involves something we call the reproducible build. But to make it simple, it's just like you have a smart contract deployed on maybe Ethereum or Near, then you're going to check the source code on the blockchain explorer, and if the code matches the one running on the blockchain in the smart contract, then you can be convinced, okay, this is the right code. Nobody has manipulated the binary code you deploy on the chain. And to move it forward, then yeah, let me quickly show you this one. We also have a yeah, let me share this. So yeah, I'm going to skip the other things. Yeah, here. Yeah, can you see this one? Oh yeah, should be okay. So when you're running the CPU TE with the GPU TE, actually the GPU become a coprocessor for the CPU, and you put them together. This is how it works. On the center side, this is the CPU TE, and basically you put your program like your Llama 3 codes in the CPU environment, which is just a virtual machine. And on the right side, you have the GPU, but GPU just follow what CPU tell it to do. So on the CPU side, you have the driver. The driver will tell GPU, okay, now you can boot up with the TE mode enabled. And once it's boot up, then the CPU and GPU TE can establish some kind of end-to-end communication, encrypted communication channel. So nobody else can see what's happening between the CPU and the GPU. So here, now you have actually two black boxes. One is the CPU and another is the GPU, and the communication between them are encrypted. So like if you're a hardware operator, you cannot see anything running inside because everything you can access is already encrypted.
So the important thing here is that GPU TE requires the CPU TE to work, right?
Exactly.
And there is no, as I said, popular GPUs like H100, H200. There is no. This is server GPU based, right? There is no CPU without confidential computing. I don't know. Yeah, that's why it works like standard. You can buy H100 and 99% it will be supplied with TE-based CPU.
Mm-hmm.
But just imagine, Alex, what possibilities gives us this architecture. You can easily run any containerized application inside of this virtual machine. You can allocate resources, right? You can get detailed metrics. You can promise to your clients fault tolerance. You can able to run restore operations. You can provide stable performance. You can use all open sourced software for your clients inside of this with no additional development. Because my question to any let's say Web3 protocol who is providing crypto-based narratives for AI ML purposes, who will develop these? I mean, 99% of well-developed infrastructure for Web2, who will run same? Because from the box, this what I mentioned, software doesn't work on ZK or fully homomorphic encryption text. Who will develop these things, right? This stuff. And in using TE, you can easily migrate everything from Web2 to Web3. Just containerize your application on Amazon and run it in confidential computing mode. That's all. Zero barrier for Web2 businesses. That's why I am always my goal is in Super Protocol. My goal is to bring first of all Web2 businesses on Web3 rails, and using this AI narrative. As I said, the AI is a great chance and maybe last chance for Web3 to be common and popular for everyone, because AI is always about private data. AI is always about how to train, how to verify models using a lot of private or well-labeled data. Who will provide this verifiability for your customers, for businesses? And collaboration is a silver bullet. And using TE, we can run, and we do it. We do it every day using this tech. That's why, this narrative works well.
Yeah, one sentence summary. So you put Web2 in, you get Web3 out. So Web2 in, Web3 out.
Yeah.
Exactly.
So I wanted. So there are two things which I think are interesting among the things that were mentioned in the last couple of minutes. One in the last 10 minutes. One is that the drawback of well, I guess there are two potential drawbacks of the TEs. One is that we do trust Intel and NVIDIA, right? So at the end of the day, if they are malicious, those private keys might have been known, right? And right. So we assume that Intel and NVIDIA are not malicious, and those private keys indeed only exist inside of the right. So that sort of if not for that, that would be the perfect solution, right? But I think the other interesting aspect, right, is that your slide mentioned SGX fails, and I know that Nukri has a very strong opinion about that website, about the vulnerabilities found in SGX, right? So many people don't trust SGX as much anymore, and for many people SGX is TE, right? People use it interchangeably, right? So yeah, what is how should we communicate to people that SGX that fail does not make the whole technology worthless?
Yeah, I think this is a great point. I just pasted the link of sgx.fail in this chat room, maybe only few guys in the space know that actually this website is created by Andrew Miller. He's one of the major contributor, and he's the main, TE advocate in the space. So although, a lot of people say SGX is insecure, there's even a website called SGX Fail, but actually the people who create this kind of website are the people who pushing the industry forward. So, SGX is awful. I admit that SGX is awful in terms of both, the security is the first commercial TE available, has a lot of bugs, and also it's very hard to use. Flashball's team has been building on SGX since last year. They have spent, I think, around half a year just to put the gas running in SGX, still with a lot of performance, regression. But in this year, we have the next generation TE. Intel TDX and AMD SEV, and also like AWS Nitro. So for this kind of new generation T is much better because Intel has already learned a lot of lessons. So most of the problems happening in the past was already fixed. I think just 2 months earlier, there was a hack on from SGX, but it turns out it was only targeting, SGX built in 2017. That's very early, and all the related bugs has already been patched. So that's why T is getting much better, and the whole industry is improving. So yeah, I think this is much better, and also for in terms of the developer experience in the next generation TEE, now you can just spend, I don't know, maybe a few days or even a few minutes to put your workload into the TEE, because now you don't need to change any code specifically for the TEE. So this is a huge improvement. This is one side. Another side I want to mention is that my mental model to think about, the security problem of TEE is exactly the same as the zero knowledge proof. Say, for zero knowledge proof, there is a theoretically, ideal model, to a mathematically correct model to make sure everything is verifiable. It's the mathematical proof. And as long as you give it the right implementation, you get this property. So this is super, appealing. On the TE side, we can also have the ideal model for the TE. You can imagine, say, there's an ideal TE where there's no, backdoor in the TE design, and the TE itself can be fully open sourced. Anyone can try to verify the implementation of the TE. Then if, say, we can somehow implement that, then the next question is how we implement that. There are a lot of technical challenges, but so does the technical challenges in the ZK space. They have the performance problem, they have the, the generic purpose computing complexity problems. On the TE side, we need to solve other sides of problem, including like how can we make sure the hardware design can be fully open source. The answer is yes, we can do that. And how can we ensure the manufacture of TE can be fully, maybe not fully open source, but fully verifiable by anyone who can, afford to do that? And the answer is we're not there yet, but we have the hope. So there are just a few things we need to figure out so that we can have some TE that has the fully open source design, fully verifiable, and everyone can even manufacture that. There are a few, hardware researchers putting their passion into building such a fully open source TE, and this is very promising. I think probably we can see the fully open source TE happening in maybe 3 or 5 years.
I fully agree.
Go ahead.
This tech, TE-based producing chips could be fully verifiable. There is no, let's say, limitations to do that, especially when fabs and architecture designers are different businesses, and they can easily verify this process. By the way, and in general terms, we do projects based on TE and other tech many years, and always security is in Web3 systems relies on cost-benefit ratio, right? Of course, you can attack in Ethereum protocol, but cost of attack is extra expensive. Same TE. Because from article to article, there are many years circulating absolutely old school narratives where patched and fixed many times, like relay attack. For example, what happens inside of TE. I can make a state reset, but same time you can easily use trusted time from TE to prevent this attack. And why? This is what I'm talking about. First of all, any technique should be used and developed by experienced teams. Regarding security, and any system could be hacked including based, ZK, fully homomorphic, does not matter. Because if algorithmical part could not be hacked, something on top of that could be. And we see a lot of hacks of traditional protocols every day. Regarding TE, I never heard any exploit or successful TE attack from user on enterprises, like huge enterprises like Apple. Try to hack iPhone. How many attacks on TE-based iPhone were successfully resolved? I never heard about that. I mean, publicly, yeah, download and hack. This is, to say truth, impossible. But same time, million of hackers trying to attack it. Same TE. TE is a very popular, including in all devices. And of course, we see attacks every day on TE. But how much are successful and how much are effective? I mean, in terms of expensive and result and cost efficient. That's why TE is always, and security is always balanced between price of attack and results you have.
Yeah. I want to add one quick point. Recently, there is a very interesting debate on Twitter. I think maybe 2 months ago. Some people claim that as long as you can have like a scanning electron
microscope, yeah,
then you can
absurd, absolutely absurd.
Yeah, and it turns out, I think the quick answer is no. Of course, no, because it's a very complicated process. But from another point of view, so say a microscope will take roughly 100K to just well, it's 100K, yeah, 100K to buy one, right? So what if we just put 2 Bitcoin into the TE, make it available for any hacker to hack. So as long as you're good enough, you can even buy a microscope to extract the key and try to hack the 2 BTC from the TE by yourself. But on the other side, if say the 2 BTC has been there for, I don't know, maybe half a year, 1 year, and it's not being hacked, that means, well, hackers, they're not capable to hack it with just the economic security of $100K US.
Did someone do that already, or that's for now hypothetical?
It was hypothetical, to say truth, Hank. Sorry, I have to say, using your charged beam, you can't read memory. It's impossible physically.
Yeah, sure.
When you're trying, just imagine, Alex. You are how works electronic microscope? You use a charged beam of particles to read structure, physical structure, I mean, of chip. But it's impossible to read memory because you are using charged beam. It's impossible. That's why it's generally from ground stage. It's absurd.
I don't overestimate my knowledge of physics.
Yeah, exactly. That's why a lot of absurd things. But realistically, to say truth, TE is the most common tech regarding privacy and security, preventing leakages of data in the world. Every iPhone, every ledger, every, cloud is using TE-based confidential computing. And of course, a lot of hackers trying to attack. And we grow with this market together.
Yeah. And regarding
Nukri,
yeah,
could you please just add about tunneling that Super Protocol is also implementing? Because no matter how secure any technology is always an opportunity to add something on the top. And
by the way, it's really interesting because we work closely with ARM. They are providing chips not only for servers, for personal devices too. And starting from version 9 or version 8, confidential computing will be available in ARM, in personal devices, on personal devices. Just imagine what possibilities and perspectives we could have using this part, because unification of these protocols and confidential computing, because all vendors work closely with each other. Just imagine what possibilities we have. We talked with major vendors. I can't, let's say, name them, but they have plans to implement verifiability attestation in all popular, let's say, browsers. And this verification will be available from the box. Confidential computing. And just imagine your data will be prevented from leakage and will be protected starting from your touch on your mobile device or on your laptop up to server where your data is computed. And everything will be verifiable. Just imagine these perspectives are super interesting regarding AI hype, regarding data collection hype, and we wanted to follow this trend. In super protocol. Yeah.
That's super cool.
Han, you also wanted to say something, right?
Oh yeah, actually that's the previous point I want to add. Since when we were talking about the SEM, the scanning electron microscope challenge, so I would like to invite every TE project to co-build, it can be like a CTF project. So we just put a few Bitcoin into TE and make it a live challenge. Just put it there, and we can even build a prediction market on top of that. So if say you can predict it's going to be hacked this year, then it effectively become a hedge of your risk, right? It become a insurance for TE usage. But if you believe it's not going to be hacked, then you can even win some money by putting the bet on the prediction market over the result of the CTF challenge.
Great idea, Han.
Yeah, let's work together to make it happen.
But to say truth, there are a lot of, let's say, requests coming from the market to use confidential computing, but there is a less number of cryptocurrencies and more about AI, prevention of cannibalization of business leakage, data leakage, and we talk with projects how to regarding the popular modular blockchains. They wanted to collaborate between different protocols. They need oracles inside of that, and confidential computing could be one of way to resolve this problem. Infrastructure to scale Web3, AI-oriented blockchains and their subnets, crypto AI payment protocols. Everywhere, when you try to scale up something, AI-based, database, big database, you have only two choices. You have to go to Amazon or any centralized cloud, which not absolutely which is out of Web3 scope in 100%, or you can use confidential computing to resolve a lot of problems. And today I don't see any other solutions, ready-made solutions, to provide these services. That's we are. And cryptocurrency, of course, is a very important idea of to keep to put a few bitcoins in TE. It's a nice story. We are ready to support it, by the way. It's interesting. We will do it exactly.
Yeah, I think that's because inherently Web3 has a higher standard than Web2. Because in Web2, say if you check the confidential computing provided by GCP, Azure, or AWS, basically everything they offer it's just a way to convince their client. Now you don't need to trust the cloud. But on the Web3, this is another story because now we want to convince everyone, literally every user, I'm not going to cheat you because I make everything open source and there's verifiable hardware. So there's no way to cheat anyone. But this is already a higher standard compared with Web2. Web2 just need to prove the good faith of a cloud provider themselves. In addition to that is early this year I also went to the confidential computing summit in San Francisco. I'm not sure if you were there or not, but it was really nice because in the past people were struggling about how to find the real world use case of Intel SGX, because SGX was the only available technology at that time. But only until this year, everyone, I think maybe 90% of the people are thinking about using TE to solve the AI related problem. It's both coming from Web 2 and Web 3. I think it is also inherently because AI is data intensive application, and it involves a lot of trust and a lot of privacy related problems, and this is when the TE solution can shine. So I think yeah, until this year we didn't see a huge demand of TE before, but in this year everything is changing.
Yeah. So I have
just
one.
Speaking with Confidential Computing Consortium, sorry, we are part of Confidential Computing Consortium, and last month we actually made the Super Tech Talk, where our CTO actually unveiled, like, on a high level, but not just our architecture, but also specific components that we have developed in order to ensure that Super Protocol is like what it is, but at the same time to explain to Confidential Computing Consortium, all the members, how can actually Web3 and confidential computing work together, and how Super Protocol specifically implements this technology. It's also available on our YouTube channel. So if anybody wishes to look at that, please welcome as well.
Cool. Okay, I have last low-level question, which I find interesting, which is, so I think today, one interesting use case that is definitely easily implementable in TE is inference, right? So you run your model, like you have the orchestrating code running in the DX. The model is running on H100 within the secure enclave. You get the but that use case in my head, at least, right? It's all enclosed in a single machine, right? So let's say I want to run training that is running on the TE, right? So then I need GPUs to communicate across machines. Is it something today, or is it something that like achievable in the future? Where are we in terms of?
It's a great question, Alex. Alex, it's a great question. Because TE is a standard and there are a lot of applications supported from the box, you can use VLLM, very well-known solution, and run it inside of in virtual machines based on confidential computing with no extra development. With zero development. Yeah.
And to H1, like the way I understand the security model, the root of trust is that the GPU TE is attesting to the CPU that it's valid. CPU is attesting to me, right? But if two machines have to talk to each other, they have to talk over InfiniBand, over NVLink. That will be like where does decryption happen? Where does encryption happen? Like when gradients flow the NVLink, how do I trust that that is not intercepted?
Yeah, we actually dig into that a little bit. So currently, I believe just from what NVIDIA has already released in their driver, now there's only 1-to-1 mapping. That means now there's only one CPU or one virtual machine. You can actually have multiple confidential virtual machine in one CPU, but now they only support to attach one GPU to one virtual machine. The reason behind, I think there's no any technical challenge. You can of course implement something like we have multiple GPU even cross the server to share some session key so that they can encrypt and decrypt together. But now from what I from what I can see is that they have only implemented the key agreement between one CPU and one GPU. You're going to pass through the GPU to a virtual machine on the CPU side, but you can only pass through one. If you pass through more, then yeah, I didn't check, but from my understanding is it's not implemented yet. But it's just a problem on the software side. It's not on the hardware side. And essentially, once the GPU and CPU are paired, they're going to do a key exchange. It's pretty similar to HTTPS. Like you use HTTPS to browse your website. So you have an end-to-end encrypted channel between the server and your browser. And here, CPU is the browser and the GPU is the server. So they have an end-to-end encrypted channel. They're going to agree on some session key so that whenever the CPU give any input to the GPU, it encrypts it first. And then it transmits the cipher message to the GPU. And once it's arrived, the message will be decrypted inside the GPU first before it gets executed in the GPU. And this also involves another very interesting observation, which is the GPU can actually run at the full speed, but the communication between the CPU and GPU has some little bit overhead. We did some tests, say the bandwidth between CPU and GPU can be 40 gigabits per second. And if you enable the TE mode, then it will reduce to I think it's 14 gigabits. So roughly 1/3 of the bandwidth. This is because now you need to do the encryption and decryption. This is a little bit overhead on the bandwidth. But beyond that, the GPU itself doesn't have any performance overhead. And if you apply this model to multiple GPU case, then there are NVLink between the GPU. It can even cross the servers. And then the problem becomes how those GPUs can negotiate and agree on some shared key so that the ciphertext encrypted by one GPU can be also decrypted by another effectively. So I think it's just a matter of the software. But NVIDIA also mentioned that in the next generation GPU B100, they're going to have this ready. They also announced that in the Confidential Computing Summit early this year.
And just a few minor in Super Protocol, you can from marketplace you can use tunneling or overlays to provide the security network between independent NVIDIA chips. I want to say that, and the link is not let's say 100 is not. You can use independent server providers to train your model.
But the tunneling, will it go through the CPU, or is it GPUs talking directly to each other?
Yeah, I think if you go with some third-party solution instead of NVLink, then I'm pretty sure it's going to go to the CPU first, do the encryption. Then you can do everything.
But
go through the CPU or not?
Of course, to say truth, Alex, in decentralized networks, to say truth, we are not oriented to serve high performance training, because training from our point of view is more about centralized teams and solutions. How to beat 100,000 GPUs bought by Elon Musk, or hundreds of GPUs bought someone. We are oriented, first of all, to serve market of usage, where privacy and security for individuals, start data and AI is important.
Well, but I do want to train a large language model on.
You always have this gap. I mean, independent servers and low latency, of course.
Quick add up to that. Although just running the unmodified codes in the TE mode with multiple TE will be very challenging, because I think it's just because NVIDIA is too busy to work on that. So we don't have native solution yet. But on the other side, I know two projects. One is Prime in Intellect, and another is Nance Research. They are pretty hot on crypto Twitter recently. They have some algorithm to reduce the training bandwidth between the nodes from like a 100-fold to 900-fold. So this is going to be huge. Although it's not comparable with just using the NVLink to do the collocated, do the training on collocated servers, but it actually make the distributed training somehow, possible. So I think this is also something I'm very willing to see how it plays out. And because, if we can actually distribute and even decentralize the ownership of the GPU, we don't need to put them in a physical, data center. Actually means that now the entry barrier to train the model can be lower down a lot. And I think this is also the vision of near AI.
Yeah. Okay, we're a little bit over time, so let's do some closing notes. If you guys want to say anything about how you envision the future of TEs, something you're excited about, or any other closing thoughts. Nukri, you want to start?
Yeah, to say truth, first of all, this year in Super Protocol, we wanted to roll out fully functional tokenomic-based testnet, and everyone is welcome. We have we'll be happy to collaborate with projects with confidential computing needs. And in Q1, we wanted to roll out mainnet for everyone. That's why we are absolutely open for collaboration, specifically in AI, ML industry and big data collaboration. And regarding perspectives, I believe that TE just starting market. TE just opening market, and specifically AI trend generates because a year ago TE was silent. And we used it in local, let's say, projects for local needs. But today TE is a gold standard. And we will be happy to collaborate with everyone who are interested in TE. Maybe.
Yeah, Yulia, you want to add anything?
Yeah, just maybe on the other side, like just recently we had one of the calls with one of TE manufacturers, and we were discussing their plans, like not even for, where we are now in like quarter 2 or 1 year from here, but they were really like talking with us about their plans and the challenges around TE that they believe needs to be solved within 10 or 20 years from now. And this is really exciting and inspiring that we live in this world, right, when we can collaborate with the TE manufacturers, right, and ensure that we are on the right level to incorporate the focus areas, the availability, the features, anything that will apply to the whole Web3 community once we are unleashing this all, but also keeping always in mind what's ahead of us, and like having it all together sounds really great. So follow us in the space. We are happy to share and really be community owned Super Protocol.
Yeah, so I can also go first, and then I will try to be quick. So yes, I think as Vitalik mentioned earlier in his blog, confidential compute or verifiable off-chain compute technologies like TE can be a perfect glue layer or glue component to connect what's happening in Web2 and what's happening in Web3. And you can't deny the demand in the market, and we can definitely see how the demand is increasing rapidly in the market. But of course, the current solutions are not perfect. And for example, the single reliance on a single hardware root of keys. So this is something we are trying to solve. And in the meanwhile, as a Phala perspective, we're super open mind to collaborate with all technologies. We are not just a fan of TE, we are also a fan of NP, CFHE, ZKP. So whatever in cryptographic based solutions can help to do something, we are open mind to help it, integrate it, and maybe working as a defense in depth. And another super growing case for our offering now is for AI. especially the decentralized AI companies and teams, if you want to bring agent SDK or AI models into your on-chain infrastructure, working with Phala is definitely something can help to boost that. So yeah, this is what we are looking at now. Thank you.
Yeah, so yeah, my closing comment on that is I think this year and the next year will be the super cycle for TEE actually. So TEE is very, very promising. And it's for a reason. First, we have the demand. Now, decentralized AI needs TEE. MEV needs TEE, Bridge needs TEE, MPC needs TEE, a decentralized front end also needs TEE. So we have a lot of demand. And we also have the right. We also get the right supply, because now we have the next generation of TEE. We have the GPU TEE for decentralized AI. So yeah, I think all the primitive, all the building blocks to make TEE to the sky is already there. So now it's our time to make it really to the sky. So on top of this, I think there are a few things I will call in action. First is that TEE is still something new compared with ZK. TEE is really new. ZK has been researched for, I think, a few tens of years. So we need more research on TEE. We need more security research. We need more education. Let everyone know what TEE is good at and what is not good at, and how can we mitigate all the risk bring by the TEE. Because we just need to make sure everyone has the right understanding so that we can use TEE in the right way. So this is the first thing I would like to call for action. The second thing is we need better accessibility to the software. Thinking about SGX, we still need to spend like half a year to build something in real with SGX. But now with TDX, it's much better. Maybe we can reduce it to 1 month. And is it possible to create some kind of software so that even average developer who don't know TEE can actually just run something in the TEE, enjoying the benefit in a few minutes, if it's possible? And I think the answer is yes. But that means we need to have some kind of high standard open source SDK, maybe with all the best security practice enabled and with all the boilerplate codes already there to reduce the burden for everyone to access TEE. So second thing I want to mention is better accessibility to the software. And the third one, hardware. Like Super Protocol is providing the hardware, and we are also providing the hardware. And I believe more and more projects is going to provide the TEE hardware for the community. So with more hardware supply, then the accessibility of TEE to the developers will be much better in the future. So I can see probably in a few months or 1 year, almost all the Web3 projects is going to use TEE as a part of their solution. And I think this can also bring a lot of benefit to them. And in terms of Phala, we are trying to work hard to solve all this problem. We're collaborating with like Flashball's team, and we're looking forward to collaborate with Near team to bring TEE very accessible to the AI builders and the Web3 builders.
Okay, awesome. Exciting times. Thanks everybody for joining us today. Thank you guys for coming.
Thank you, Alex.
Thanks for having us.
Thank you.